Assalamu alaikum students. Hope you all will be fine. Today I am going to discuss the topic name is differential equations. Today's lecture is very important for those students who wanted to continue their career as a teacher, or they want to teach higher classes like graduation or post graduation level. They must have to see the lecture which I am going to deliver today. The differential equation, first of all I want to define the definition. What is the definition of differential equation? An equation in which derivative of a variable which is dependent with respect to one or more variables which are independent its higher powers and higher orders are involved is called a differential equation. So this is the basic definition, or you can say that such kind of definition which can convey everything about a differential equation is in front of you. An equation in which derivatives of a variable which is dependent with respect to one or more independent variables and its higher powers and higher orders are involved is called the differential equation. So this is the definition. I want to explain these terminologies which I have used here. Okay, I am giving some examples in the favor of my definition. Example number 1. This is my first example. D square y by dx square plus 2x dy by dx plus y is equal to e power x. This is my first example. The second one is d cube y by dx cube plus k times y dy by dx whole power 5 is equal to some constant 5. Third example is dy by dx plus pxy is equal to qx. Fourth example is d square y by dx square multiplied by x square plus x dy by dx plus y is equal to e power x log x. Fifth example is x partial u by partial x plus y partial u by partial y is equal to 2xy. Sixth one is partial square u by partial x square plus partial square u by partial y square plus partial square u by partial z square is equal to 0. So these are 5 examples of a differential equation. You can see there are 5 examples of a differential equation, from which 1 or you can say 6 examples are there, and from which 4 examples are for ordinary derivatives. So these are the ordinary differential equations, means ODE, and the last two contains partial derivatives, so these are called partial differential equation. So you can say that a differential equation is of two type. One is ordinary differential equations, which involves ordinary derivatives, and the second one is PDE, partial differential equations, which contains partial derivatives. In all these 6 examples, you can see that the dependent variable which is in the numerator of each fraction is only one. So any kind of differential equation, which may be an ODE or a PDE, contains only one dependent variable. In first four examples, this dependent variable is y, and in the last two examples, the dependent variable is u. And what is the independent variable here? So in first four examples, the independent variable is x, and in the last two examples, in example number 5, there are two independent variables, one is x and one is y, and in the last 6 example, the independent variables are x, y and z. So it means that our differential equation contains only one dependent variable, but can contain one, two or more than two independent variables. So if a differential equation contains only one independent variable, then it is an ODE, and if a differential equation contains two or more than two independent variables, then it is a PDE, partial differential equation. So this is the first scenario which you should clear about the differential equation, that a differential equation can be of two types. Now, one thing I want to explain here is that I write the definition. I have written the definition of a differential equation, that a differential equation contains derivatives, its higher powers and higher orders. So you can see there are so many terminologies used here, which are the derivative terms. For example, in the first example, there are two terms of derivatives, and the first term is of second order derivative, and in the second equation there are also two terms which involve derivatives. The first one is third order derivative, and the second one have some power 5 of first order derivative. So it means that in a differential equation, derivatives of higher orders can be involved, or its higher powers can also be involved. So this is the main definition of a differential equation, and you can see that there is only one dependent variable, and there are many examples in these 6 in which there are more than two independent variables. So you can say that a differential equation can be defined from all these 6 examples. Now I go forward and I will explain that what should you know about the second thing of a differential equation. It will be its order and degree. Order and degree of a differential equation. So this is the second main important thing about a differential equation. Order of a differential equation and degree of a differential equation. First of all, I will like to define order of a differential equation. So I will write the definition of order of a differential equation. What is order of a differential equation? The order of the highest order derivative involved in a differential equation. I abbreviate the differential equation word by DIFF-EQ. You must understand that it is written the word differential equation. So the order of the highest order derivative involved in a differential equation is called order of this differential equation. So you can say that the authority to set the order of a differential equation is under the belt of the highest order derivative involved in a differential equation. What is its order? It definitely becomes the order of the differential equation. So if we write an example that there is a differential equation like this, d square y by dx square plus y dy by dx plus y is equal to 0. So I wrote an example of a differential equation, and from this example you can see that there is the second order derivative is involved in this equation. So the highest order derivative is this, and order of the derivative is 2. So differential equation order is also 2. So order of a differential equation is defined like this. So now I will go towards the degree of a differential equation, and then we write some examples, and we will see that what kind of classification we can give a differential equation written in the examples. So I will go towards the second part of the heading, which is the degree of a differential equation. So how we can define the degree of a differential equation? Degree, the second part. So how we can define the degree of a differential equation? The power of the highest order derivative involved in a differential equation is called degree of this differential equation. So I should recall what I have written, that the power of the highest order derivative, again the word highest order derivative is involved here. The highest order derivative power should decide what is the degree of differential equation is. For example, if we write a differential equation like x square d square y by dx square plus y times dy by dx power 5 is equal to e power x. So it is an ordinary differential equation. The highest order derivative is d square y by dx square. So I must look the power of this highest order derivative, not this one, because it is not the highest order derivative involved in the differential equation. This is the highest order derivative involved in a differential equation, and its power is 1. So you must say that the degree of this differential equation is 1. So I think so from this example and from this explanation you should understand what I want to convey you about the definition of order and degree of a differential equation. So I must recall here what we have learned from this lecture. First of all, what is the definition of a differential equation? Second one is that what kind of differential equations are. There are two kinds of differential equation. One is ordinary differential equation and the second one is partial differential equation. Then we went towards the order and degree of a differential equation. I defined already that what is the order of a differential equation and what is the degree of a differential equation. Now I must go towards a very important branch of a differential equation. The name is linear and non-linear differential equation. Linear or non-linear differential equation. We can abbreviate linear differential equation as LDE. What is the definition of linear differential equation? I must write there. So definition is an equation in which the power of the dependent variable and you know that there is only one dependent variable, so I can't write here the variables word. I must write the dependent variable, the power of the dependent variable in each term. So I must write here a differential equation. So a differential equation in which the power of the dependent variable in each term should be 1 is called an LDE, a linear differential equation. Otherwise it is a non-linear differential equation. It is a non-linear differential equation. So linear differential equation is very simple to understand. I must give the example here, but I must conclude something from this sentence, that dependent variable used in ODEs in the previous example which I have written in this lecture was y. So y have only one power in each term, then it is a linear differential equation. Otherwise it is a non-linear differential equation. But nowadays the research is advanced research is revolving about non-linear differential equations, because it is very hard to solve every kind of differential equation, non-linear differential equation analytically. There are so many methods, numerical methods, through which we find the solution of such differential equations which are non-linear, and their solutions are not easy to find analytically. So the researchers' interests are in this term. That means non-linear differential equation is very important in nowadays research. Linear differential equation have not such kind of importance in today's research. So I must write here some kind of example of a linear differential equation. I have written here already dy/dx plus pxy is equal to qx. This is a general kind of a linear differential equation. You can see that there is a dependent variable y involved in two terms, and the power of the y in each term is 1. So it is a linear differential equation. But if I attach some variable pxy square, means I just raise the power y towards 2, it is a non-linear differential equation. Even if I wrote the differential equation like this, y x d square y by dx square plus y dy by dx is equal to 5 e power x. In this differential equation, even this is first order derivative, power of y is 1, power of y is 1, power of y is 1, but if we multiply this term, the power become 2, so it is not a linear differential equation. Y power is 2 here, so it is a non-linear differential equation. Non-linear differential equation. So it is the definition of linear and non-linear differential equation. So now you can classify any kind of differential equation, that it is linear, non-linear, ordinary, partial. So I write here two examples. One is dqy by dx cube plus 5xy d square y by dx square plus dy by dx plus 9y is equal to e power x sin x. If this is a differential equation, obviously it is a differential equation, and if we write the classification, first of all it is an ODE. Second one is, what kind of second property we can write here, it is an ordinary differential equation. Second one, what is the order of this differential equation? Order is 1, the order is 3, highest order derivative is third order. Third one is, what is degree of this differential equation? The degree is 1, because the highest order derivative have power 1. So it is whether it is a linear or non-linear differential equation. Obviously y multiplied by this show that it is a non-linear differential equation. So I think so. Now you can classify any kind of ordinary differential equation by these four terminologies. Now I must go towards the example of a partial differential equation. I write here u partial square u by partial x square plus partial square u by partial y square is equal to k times u. It is a PDE, partial differential equation. Second one, it is a second order differential equation. Third one, its degree is 1 because highest order derivative have power 1. Fourth one, it is a non-linear differential equation. So I must go forward from this definition. In the next video I will explain that what kind of differential equations can be written for BVPs or IVPs. So I must explain these terminologies in the next video. Thank you so much. Please subscribe my channel for my latest videos and for very informative information about the PPSC and other things. Thank you so much.